What we want to do today is we've been working, and there's a team here. You see the list of people on this group. Ray and I have worked together for many years on a lot of water management issues in Nebraska, and we've been pretty blessed to be able to find a group of people help us put a lot of this stuff together. Chris Thompson is a PhD. We hope he finishes. We'll see a PhD student in ag economics that did a lot of the work for us, and then beforehand Brian McMullen did a lot of work for us. And then Scott Nevid was one of the first people who really helped us get the thing off the ground. We've also partnered with Gary and Paul from out in the Panhandle, so we've had a nice mixture of a lot of helping people. And then in addition, we've had a nice partnership with various educators at UNL. Chief among those would be Chuck Burr, Steve Melvin, and Gary Stone have done a lot of work. Gary Zobak to some extent too. So we've had a nice team. We worked on this for quite a while. So what we want to try to do today, I guess, is we're not going to show you a lot of computer runs. We've developed some software you can use. We're not looking at doing that. What the theme of the day is really going to try to be about is what have we learned and what are some take-home messages that you can have. So I'm going to start off by kind of laying the groundwork of how we do this. I'm probably going to go through the boring stuff. And then a little later on, the guys are going to talk about, what are we seeing out there that might be some recommendations that you can employ without having to do a whole bunch of analysis, perhaps. We still have the computer available, the program available if someone wants to get into the nitty-gritty details. So I'm going to talk a little bit about deficit irrigation management. What we're looking at here then is a map that I'm sure you've seen many times, looking at the changes of groundwater levels in the state of Nebraska, and that's been driving water policy in many of the areas across the state. We have endangered species issues, and so today we're challenged much more than ever to manage this water resources. And so part of this, we also are very actively trying to do a better job of figuring out the connection between groundwater and surface water. And so really this kind of resource base has led us to look at how we're going to manage our watershed. And I think that's the theme of the future. Things that are changing as we speak are our productivity. Thank goodness we have great varieties. Regulatory changes are happening almost continually as we go. And then price cost volatility, I don't have to tell you what that means out there today. So, if you think back even 6 or 7 years ago, diesel fuel cost $1. What was the price of corn then, So our whole world's kind of changed here in the last 6 or 7 years in this process. A slide I always like to focus on is looking at the amount of rainfall variability in the Great Plains. Not just Nebraska, you can go all the way to the Panhandle of Texas, but on average, we see about 1 inch of rainfall variation. Average annual rainfall varies about 1 inch for every 25 miles you go east to west across Nebraska. So if you go from Kearney to North Platte, that's about 100 miles. That's 4 inches variation in rainfall. There's more variation in rainfall going from Omaha to Scotts Bluff than there is if you go from Omaha to Norfolk, Virginia, or if you go from Scotts Bluff to Sacramento, if I don't include the mountains. And so we're in this range of extremely rapid change as we go east to west. And I'd like to have you lock on that number because as we show some results today, kind of put in your back of your memory, well, I'm 50 miles east or west of here, that's going to be a couple inches difference in some of these kind of numbers that we're going to talk about. Another issue, if we look at what we're trying to do to balance water in Nebraska, this is a slide looking at a real rough water balance for the state of Nebraska. So on average, we get about 22.6 inches of rainfall a year is our average rainfall. Down around Falls City, we get about 39 inches, and out in the Panhandle, we get 15 inches on average. But on average, we get about 22.5 inches. We have about 9/10 of an inch of water equivalent that flows into Nebraska from the western states. We export in surface water about 2.3 inches of water, so about 1.4 inches of water that we add to stream flow, that precipitation goes to stream flow. We have some water that we use up here we call other consumptive use, and that's mostly water for cooling. A lot of that's for coal-fired or other types of cooling that's used in generation of electricity. Some of that's used in the ethanol industry, but not a great deal. But the big number here is the amount of evapotranspiration that's occurring on the land that we farm and ranch. If we look at a gross balance, about 88% of that precipitation is going back into the atmosphere as evapotranspiration off lands that we farm and ranch. And so if we look at how much goes to an increase in precipitation, it's about 6 inches. And if we look at the impact of the fact that we irrigate about 8.5 million acres in Nebraska today. That's somewhere just a little bit over a sixth, maybe almost a fifth of the state now that we irrigate. About half the state is still rangeland. And so when we look at the increase in evapotranspiration that occurs because we irrigate, that amounts to about 8% of this total evapotranspiration that we receive. And so we're trying in our research, we're trying to look at ways that we can manage evapotranspiration on other lands and not just put it all on the back of the irrigator out there. But that's a research program that we're working on, and I know you guys are doing reduced tillage and things that are contributing to that. So, okay, so the outcome of all this has been, establishment of policies in terms of, how we're going to manage water by the NRDs. And so I've kind of got two things on here. Hopefully you can see it okay. I broke it into allocations where growers are allocated a volume of water that they're going to be able to use in some defined period. And so this is groundwater that I'm thinking about. So those that are looking at an annual allocation program would be the single hatched areas here. So one of those is going to be the lower. I understand that the lower Republican is considering going to a one-year allocation program. If you look at the ones that are kind of double hatched, it's a program like in the middle, the upper Republican, and then out in the western and the Panhandle. Those programs, they've looked at an allocation of a given quantity of water over a specific amount of time. And so, a common theme would be, for example, maybe 13 inches of water over 5 years. So that is, 65 inches that you could use per irrigated certified acre. So we've tried to develop some analytic tools to look at that case where you have an annual allocation, you have to use it or lose it. And then we also have looked at those where you can carry some of the water over and make use of it in a future time if you ever get one of those wet years out there again. We also have in this map the ability to expand irrigated area. And so if we look at this darker purple area here, we're looking at areas that now they have a moratorium really on developing wells and certainly a moratorium on expanding surface irrigation. When you look at when you look at the limited area, these areas in the Loop and the Elkhorn and the Niobrara and those areas, after the failed analysis to look at declaring those as being fully appropriated, the NRDs realized that there would probably be a run on developing irrigation, and so they put in some controls that limited how rapidly people could develop irrigation there. There's some other NRDs like the lower blue NRD that's whether they want to look at some kind of program or not. So, we're looking at these regulations, we're looking at these allocations, and I'll just ask the question, which way do you think these allocations are moving? Are they moving east or are they going west? Yeah, they're moving east, aren't they? We're looking at more and more of the state falling under these allocation programs. And so one thing I'd really encourage you to do if you're new to this is talk to people that have been under this for a while. I think Greg's back there. How long has it been? You guys started allocating in 1977, I think, didn't you, in the upper Republican? And so, the sky's not going to fall. You can put together some programs that make some sense going forward. So visit with some of your colleagues who have been in the game for a while if you're new at it. It's all about managing this watershed. And what's driving us today, and a lot of what we do, is the outflow out of the watershed, whether it's to meet interstate compacts or whether it's to meet in-stream flow requirements for various endangered species or downstream neighbors. What's really driving us today is trying to get more of that water in that stream. We've worked for a lot of years developing systems that are really efficient out here, getting water for crop water use, and so we're really kind of now beginning to rethink some of this water balance in our system. So sustainability, I think, is that issue. I'm not going to read all this to you. That number 3 is one where I don't think we've done a very good job at all at thinking about how do we look at groundwater in terms of sustainability. I think we should view it more as a reservoir and not so much, so it can go up and down, up in the wet periods, down in the drier periods, and maybe we can manage that over a time period to meet some societal goals there. We really need a systematic approach to this, and we really need, I think, a lot more dialogue in managing this water. Okay, so kind of as a background for that, that leads us into what is deficit irrigation, why are we talking about that? And some of the questions we have to deal with is, well, how much stress would I allow? This is an example of a corn crop that we've allowed to be stressed, and this is about at the 12-leaf stage, and so is the stress at that time of the year, when I stress that, what impact is that going to have? Ultimately, of course, your banker wants to know, well, what's that going to cost? And then how do different crops respond? And so we've tried to kind of look at some of those factors. So what is deficit irrigation? Deficit irrigation is applying less irrigation annually than is required to fully meet crop needs and in an amount that results in a reduction in crop yields. So, if you happen to be maybe over-irrigating the last few years and if you cut back an inch or two and you didn't have any impact on your yield, then we wouldn't say that that's necessarily deficit irrigation. There needs to be a reduction of yield and a reduction of evapotranspiration for that to truly be a deficit irrigation scenario. Well, what are some of the things that lead to us doing that then? Are annual shortages of water, whether it's canal limitations that you're looking at, in several of the basins now. Could be these annual, multi-annual allocations. Sometimes limited irrigation capacity leads us to that in the drier years. Could be if water was really expensive relative to commodity prices, that might be to your advantage to take a little stress. Also, sometimes maybe the desire to transfer some water, maybe have an opportunity to sell some water to someone else, and so maybe that's an alternative that I might take a little stress. I'm going to look at some of the alternatives. Instead of deficit irrigating, let's look at some of the alternatives we might go through that would mitigate some of the impact of water shortage. Some of the decisions you have to make, or the comparisons you have to look at, is do I fully irrigate? If I have a 130-acre pivot, do I try to fully irrigate a smaller part of that pivot? Maybe 100 acres and I'll leave 30 dry land or something out there. That's a choice you make. One choice you might look at is becoming more efficient. Maybe I'm going to change out that old system, go to something maybe more modern that has more control and more precision. One we get a lot is changing crops. I know 10 years ago in 2002 we had a lot of people saying I'm going to go to wheat, and that's a knee-jerk reaction we'd really like to try to convince you not to go to. Shifting water requirements during the season. If your capacity is limited, there may be reasons why you'd want to have maybe half a field of soybeans and half corn. And then try to schedule that stress to occur when it's least costly to you during that growing season. What happens when you deficit irrigate? Well, obviously stress is going to develop during the season. It's going to lead to ET reductions. We're going to talk about a linear yield ET relationship. I'm going to show you some of that. Gary's going to show you some of that. I want to convince you that irrigation efficiency is not a constant value. We talk about pivots being 90% efficient. Well, I can mismanage it and be a lot less than that, but I can also, in deficit irrigation, I can get a lot more efficient when I stress the system a little bit. And then additionally, towards the end of the day, we're going to talk about planning problem versus a management problem. A lot of what we're going to talk about today is going to be a plan. So we're sitting here now before the first of the year, and we're trying to make a plan on how many acres and what crops I'm going to plant next year. And statistics will show you that the best predictor for that is going to be the average annual conditions. I mean, that's the most likely thing to occur. It's never going to occur, but it's the most likely thing to occur. Once you get into the season, the problem is now I'm in the real world, and what I thought I was going to get from rainfall on average didn't occur. So what am I going to do to make a difference there? And so we'll talk about that a little bit if we have enough time right at the end of the day. So let's think a little bit about what can producers do. As a producer or a water manager out there, what can you do if you're faced with this deficit irrigation issue? And so there are a lot of opportunities that can be made. Certainly long-term there are changes that we can make in the watershed management. There are a lot of things we can do on farm to improve our management. And with all of the great developments in variety and genetics, there's a lot of change in what we can do what our opportunities are to put commodities out there. Now, those of us in the university aren't going to say an awful lot about varieties here. We hope maybe Monsanto will make a few comments about what they're seeing here in terms of varieties when you start to think about planning your water management program. We have to start asking, where's the water go? And we have to be a lot more interdisciplinary than we've been in the past, I think, to address this problem. So that's why we're kind of excited to have economists, agronomists, and an engineer involved in this. And also, we have to look at tools that help you do some of this accounting. Okay, what are some things you could do? Don't you think about the first thing people think of is I'm going to get more efficient? That's what we hear a lot. I mean, if I look in areas that have been allocated, it's all 100% center pivots now, basically. Some of the places have went to some subsurface drip. But really what most people have done is they went in and they've converted from these older systems to these new systems and, been able to achieve, really what you're doing is you're getting a higher percentage of the water that you're allowed to pump is going into evapotranspiration, okay? That may or may not solve the problem at the watershed scale. It helps you in terms of your bottom line as a producer. So when you go to improve technology, you get reduced runoff, less deep percolation. You can apply a smaller amount of water that better meets the current crop water needs. So that last irrigation of the year, I can put on 3/4 of an inch instead of putting on 4. And so I can better really target that water application. And of course, labor is an issue out there today. Those are all the good part. If you don't need to pump quite as much water per acre, some people then look at the opportunity where it still exists to expand irrigated area. And this number 2 is one where that's not helping our watershed for sure then. If we use improved efficiency to be able to irrigate more land, almost certainly our consumptive use in the basin is going to go up. It's to your advantage to do it. It's a paradox. It's your advantage to do that. You can make money doing that, certainly in today's world, but it's not helping the watershed if we continue to expand that irrigated area in some places. So changing method is certainly one thing people have looked at. I'll let you look some of these and look through what we do here. All of these have the potential to improve efficiency. Just because that system happens to have the ability to go 90% efficient doesn't mean everybody's going to get there. Changing the amount of land that you can irrigate. This is one that's a little bit harder sell for some folks. We're going to talk later today. Dr. Spalla is going to talk about maybe some guidelines you can use to decide when it's your advantage to reduce the amount of land in that field that you irrigate compared to irrigating the full field. The other thing we hear a lot is that people say, well, it's too risky to take some stress on 130 acres. I'm going to cut my acres down to 90 acres and I'm going to go for full yield. That's we would like to have you think about the problem. Let's go back to 2011. We get a wet year, and if you'd only planted 90 acres and you got 40 acres out there that are not very productive, you could have had full yields in 2011 on that whole 130 acres, and so cutting back those acres would have been a really bad decision in 2011. What you find out in a year like 2012, it doesn't make a lot of difference whether I cut back to 90 or I go 130 and take some stress. So I want you to think about, kind of the money you're leaving on the table if your goal is to get maximum yield on reduced area. There's a risk there that's kind of hidden in the background, and I think Dr. Spalla may mention that a little bit later on. I can change crops, and this is one that a lot of people think of, and we're definitely going to hit this in more detail. To be quite honest with you right now, it's really hard to knock corn out of this list. I mean, the value is pretty good there, and the yields are great. But we'll talk a little bit about how you can select different crops and go through different strategies to look at this. This is one that's win-win-win, and certainly we encourage you to have good agronomics. Gary may make a few comments about that. Gary Hergert may make a few comments about that in a minute. But residue is one that is, especially as we're going this heavily to pivots, is one where we really see some, encourage you to think about getting more residue out there and managing that tillage so that we can get better infiltration. We can shade that soil. We don't have the non-beneficial use of water for ET, evaporation. And if it ever does snow, maybe we catch a little of that snow as well in this system. This one here, certainly at a farm perspective, it's really hard to see how this isn't win-win. It may or may not be win-win at the watershed level. This is going to cause you to set some new management goals. we're gonna, you're gonna have to think about, well, what's the right target, and then you're gonna think about how I can maybe hit that target. And there's going to be some tools out there you might need to use to do this. Irrigation scheduling, we think, is still important. Maybe soil moisture monitoring can replace irrigation scheduling as we used to think about it, and it can be very valuable in doing that. There's a lot of nice new tools available. This is actually an old picture, but some nice new tools that are available to let you really precisely manage some of these systems. And there's an old rule: you can't expect what you don't inspect. We have to still get out there in that field and manage it at the ground level. Monitoring soil moisture is something that's we think is becoming very feasible. We've got some systems where we put watermark systems in, and we've buried the line underground about 400 feet to get out to a data logger that you can push a button and you see 35 days of record of your moisture at 6 different places in the field. That costs us about $800 a field to do that. The cost to send that pivot around is probably anywhere from $1,500 to $2,500 just to send it around one time. So you can pay for all of that in less than a full revolution of a pivot. Some of the other technology, the John Deere technology and other types of technology that's more directed to getting information out on the web is much more attractive to people. It's a little bit more expensive, but you get a little bit more service out of that. And it's a very viable alternative as well. But there are great tools out there today, and we really strongly encourage you to start monitoring that soil moisture. I don't think any of you are going to go out and take the gas gauge off your truck and drive it around, okay? And so this soil moisture monitor is just like that gas gauge in your truck. How do you know when you need to refill your truck if you don't have that gauge? And that's what this soil moisture monitoring is doing for us. So it's really reachable right now in terms of current economy. Some of these improvements may increase ET. And so now when we look at the NRDs have had to go in and establish a allocation program, and they're doing that whether they kind of think about it or not, but they're doing that based upon kind of an expectation of what people's efficiency is going to be. And so they give you an allocation. And then logically what you do is you become more efficient, better managers. And so, invariably what happens is that you end up consuming a higher percent of the water you're allowed to pump than maybe they had planned on. And so what's the NRD have to do to balance the watershed? They have to look at, well, maybe we have to cut our allocation back a little bit. And so some of my friends say, well, that's really an inefficient way to go about managing water. That you're always kind of making these corrections. But I would point out, I think that's a great program, because what I think it has done is it allowed you to innovate. I mean, the innovation that's occurring out there in these limited areas is phenomenal. And I think is a strong encouragement for you to get better and better and better. And what that ends up doing is really enhances the value of that water that you're allowed to pump. We understand the NRDs may have to reduce the allocation because they get more efficient. But I got a whole much more value out of that water that I could pump now than I would have had if I was just doing the same old thing 25 years ago. So while it may not be the most policy efficient method, I like it because it really does stimulate innovation and I think maximizes the value of that water. A new technology that's out there, and I don't know if this works for some of you. This is a slide I stole from our friends here from Valmont, Kelly and Craig, but there's new technology out there now where you can look at variably applying water around the field. And maybe something you want to look at in this deficit irrigated. If you look at this technology and you look at where we're at in a deficit situation, if you have a variable field out there now, let's compare the situation where you're deficit irrigating or you're limited in water to a place, let's go back in eastern Nebraska, where I don't have a limitation on how much water I can pump. Well, how could you pay for improved technology? Well, I mostly do that by being able to pump less water. So it's really the cost of pumping the water that determines kind of what my marginal value is that I can invest in some of this technology. Let's come out here now where we're in an allocation program and I can't pump more water. And if I have an area out there in the field, maybe it's this blue area up here where I don't need to put maybe I can put this up on that hilltop. Now, how do I pay for this? It's not the pumping of the water. You're going to pump all the water. The difference is now, what's the value of that water by being able to have an extra inch of ET up on the side slope or the hilltop? And right now the slope of a yield ET line is about 13 bushels per acre inch for corn. So if I can get 13 more bushels per acre inch on the side of that hill, pump the same amount of water, that's a whole bunch more money to pay for some new improved technology than what there would be if all I'm doing is looking at my pumping cost. So this may be a technology you want to think about, look around a little bit. There are a few systems out here. It may or may not work in your system, but a lot of people I talk to that develop this technology, they're saying they think deficit irrigated areas is where this technology may be the most attractive right now. Well, we have to ask this question, where the water goes. And so this is kind of my depiction of some of that. This is water that we divert or pump. We can have evaporation losses, runoff, deep percolation, going back into recharge of groundwater, runoff that's reused or returned, and then ultimately crop evapotranspiration. This is the only one of the group is beneficial. This produces a value from us. This one here doesn't hurt anything. It's kind of like we're recycling the water. Either we're putting it in the stream to meet our in-stream flow, or it's going back into groundwater recharge. Excuse me. The villain on this is kind of this non-beneficial ET. So in a lot of ways, shifting non-beneficial ET, evapotranspiration or other surface losses, into beneficial uses of water, you know, the watershed's the same. You know, think about it. If you have water running down a road ditch out there and there are pigweeds using that water, that's not beneficial to anybody. So if there's a gain of water there that we can make, if we can take that water and put it over to a better beneficial use or recharge it, you know, those were some of the opportunities I think we have, and that's why I think we have to focus on where does this water go as we do this process. So kind of as a summary, some of the management choices that we have here then for insufficient irrigation supplies: we can reduce irrigated area, we can reduce the amount of water we apply to all the acres, we can substitute crops with lower water requirement, delay irrigation, manage that soil water to capture more precipitation, maybe convert to a better, more efficient system. In some cases, if you have the alternative, maybe you want to think about buying water. How are you going to price that water? What's it going to be worth? Most likely, you're going to look at a combination of all these things when you do this. In order to evaluate this, what we have to do is we have to look at the productivity of the water. How much yield do I get for the water that I use? And we look at this in a couple of ways. You're probably going to see this slide so many times a day you get nauseous of it. But we can look at the relationship between yield and ET, and I'll show you data here in a minute that these lines are linear for all the crops that we're going to really consider here in the Great Plains. So as I increase ET, I get an increase in yield. But the blue line is how much irrigation water I applied. So if I applied this much irrigation water, I get this amount of that irrigation went to ET, and this amount of water went to what we call a non-ET loss. Well, what would be some non-ET losses? Well, maybe evaporation of water off the canopy that didn't reduce transpiration, maybe runoff that got in the road ditch, maybe deep percolation that I couldn't control. So anything that didn't go to evapotranspiration can be a component in that. And so this is how the crop is responding. This is how your irrigation system's responding. And we have some methods here. We think that we can relate those two together. We come back to this deficit irrigation then. We still have those same 4 points we talked about before, but I'm going to add number 5 now. You know, we can do a lot of these things. We can get more efficient. We can put in reduced till. In a lot of ways, what we're doing there, folks, I think is buying some time. I think in a lot of these areas, eventually, we're still going to be facing the deficit irrigation problem. We might delay that a little bit by improving our technology, but most likely, we're going to face deficit irrigation down the road anyway. So we think that you know, we need to look at it now, even if you're not quite there. I think we've talked about that. Let me give you just a few numbers here then to think about. Well, you know, how big a deal is this? How big a hit am I going to take if I start stressing this crop? And so I'll show you some data that Steve Melvin and Joel Sneedcloth and Norm Cluckey did some work on for over a long period of time in southwest Nebraska, looking at, really they looked at 4 different water management strategies. What they did is took a center pivot and divided it into 4 quarters. And in the first quarter here on the upper right, they allowed the farmer to do what he normally would do. Okay, they didn't try to change any farmer practice. In the lower right, in the blue, the scheduled one, they went in and all they did was schedule very carefully to produce maximum yield. So it's no yield hit here, just really good water management. The yellow is a program called Water Miser, where what they did is they shortened up the length of the growing season. So they delayed irrigation in the first part of the year and cut off irrigation earlier at the back end of the year. And then the last part was a deficit irrigation program where they looked at some pretty significant reduction in water application in the field. Now, they tried to do simple systems that, that would be something people could look at and see the impact. Yeah, okay, I think I described those well enough. So here's some results. Now, this is a period, this is not just 1 year, this is a period 7 years, 6 years, I guess, 1996 through 2001. The work went from Arapahoe to Benkelman in terms of areas. The area at Dickinson was a pretty sandy soil. So you can see the second column here is showing the amount of water that the soil would hold in inches of water per foot. So these 2.0 values are silt loam. This 1.0, excuse me, 1.0 is going to be a sand. So when you look at what the farmers put on over this period of time, the average at all the sites, they averaged 12 inches of water application over all those locations. Okay, and that's just the farmer doing his own thing. Now then, when we went to irrigation scheduling, putting in moisture monitoring and kind of watching ET, by doing that, they were able to save about 1.5 inches of water. They got down to about 10.7 as the average application over that time period. So when we went to the Water Miser, where they just shortened the irrigation season kind of from both ends in, they ended up with a total application of 8.4 inches on average for those locations. And then lastly, when they went to the deficit irrigation mode, they put on 6 inches of water on average. So if we use the farmer's value as a reference point, by just doing good irrigation scheduling, they reduced the water application by 13%. When they looked at the Water Miser, they actually reduced the volume of water pumped down to 70% of what the grower was applying. And then 50% on the deficit. So we're 50, 70, 87, and 100. Okay, that's how much water we applied. Let's look at the yield now. You look at the yield, the average yield of the farmer was about 191 bushel, roughly the same thing for the well-scheduled, well-managed system. They're both around 190 bushels of corn. When we looked at the Water Miser, they averaged 185 bushel of corn. So they got 97% of their yield. And what percent of the water? It was 70%. So they reduced their pumping by 30% and gave up 3% of their yield. Okay? And this is not a one-year deal, folks. And this is not us picking a small plot. We actually let the farmer pick his quadrant first, and most of them are smart to pick the best quarter, okay, of the pivot. But we reduced pumping 70%, and there's a 3% reduction on average yield. How about the deficit? We had 171 bushel there, so you had almost 90% of your yield. And what was our pumpage? It was half of what the grower had normally done. So, and I'm not saying that there's anything magic here, but what I want you to understand is that, the sky's not going to fall if we put a little bit of stress on these crops out there. We've shown it time and again, colleagues around the country have shown that we can put some mild stress on these crops and we don't pay a big bill for a yield reduction. I'm not going to tell you there isn't some hit, and I understand with $7 corn, that's real money. But, the sky's not going to fall necessarily if we cut back this water just a little bit. We've developed a program we call Water Optimizer. It's an Excel-based program that we look at that you can run to do some of these calculations. It kind of helps you deal with this question of what crops should I irrigate, how many acres, what kind of net return could I expect, and what are some of these trade-offs. And we have it available. You can download it. We'll give you the site later if you want to download it, play with it. It's a little bit complex. Okay, it's a little more than a little bit complex. But today what we're going to do is we're going to talk about the results from using that, not necessarily talking about you using that. So I think with that, I would stop and entertain any questions or comments. My goal here was to kind of set the ground of what the rest of the guys are going to try to do. Yes, sir, over there. Okay, so the question was, if I get it right, the question was on those quadrants, did they treat their agronomic practices the same on the fields, fertilizer and seed and all that. Yes, they did. Yeah, they were all exactly the same. So the question was, just to let everybody hear that, is what kind of farming practices were employed here? Was it reduced tillage or not? You know, there's a variety here. There wasn't. They didn't change what the farmer was doing. So we have a mixture included in this. Generally, if we can do reduced till, we're going to be a little bit better off than in terms of some water stress than we are with, you know, with higher levels of tillage in the long. Okay, so the question was, is plant population constant across those? And yes, I think it was. I think what they really did is they went out, the farmer just planted the field as he normally would, and they went out then and just controlled the pivot as he went around those quadrants. And, you know, there's Gary's going to have a little bit of information on plant population in some of his slides in a little bit. But, you know, there's a thought out there that if I cut back on population, I'm going to reduce ET. But really what you have to cut that plant population a long ways back to save much ET. So I'd rather have you think about if I don't have the yield potential out there, if I'm going to be reducing my yield potential by 30%, well, by this 10%, it's really a better question, how much can I save in seed cost, I think, rather than saying that I'm going to reduce population enough to reduce ET. Because if you try to reduce ET, what you end up with is you're going to have a lot less yield potential out. I think that's fairly consistent with Gary's comment.